Holly made a number using these digit cards. The hundreds digit is greater than 4. Holly's number is odd. What number did Holly make? So if the hundreds digit is greater than 4, we can't use 4 for the hundreds digit. We'll need to use either the 8 or the 5. But we know that Holly's number is odd, and an odd number has to have a ones digit of 1, 3, 5, 7 or 9, because an odd number is not an even number. But the only odd digit that we have here is the 5, so that means to make the number odd, we need to use the 5 as our ones digit, which means the 8 has to be our hundreds digit, because the hundreds digit has to be greater than 4. So that means 4 must be the tens digit to give us the number 845. Write one number from each circle to make this calculation correct. Something times something minus something equals 0. Now notice the options that we have here are all multiples of 10. So if we want 0 as our answer, we'll want the product of our multiplication to be a multiple of 10 as well, because then we can subtract a multiple of 10 to get 0. So 5 times 6 gives us 30, and then if we subtract 30, we'll get 0. Or we could have 5 times 8, because that gives us 40, and then 40 minus 40 gives us 0 as well. So there are two different possible solutions for this question. Class 6 collects litter from a park. This chart shows some of the litter they have collected so far. How many bottles have Class 6 collected? Well, if we look at the key for the pictogram, we can see that one bottle on the pictogram represents 100 bottles. So we have 100, 200, 300, 400, and then we have half a bottle. So that's half of 100. And half of 100, or 100 divided by 2, is 50. So the full bottles each stand for 100, and the half bottle stands for 50. So that means they've collected 450 bottles altogether. Now, how many more bags than cans have they collected? We can see that a full bag stands for 100 bags. So we have 100, 200, 300, 400, but then we have 1/4 of a bag. So to find what this represents, we can find 1/4 of 100. If we divide 100 by 4, we get 25. So a quarter of 100, a quarter of a bag, represents 25. So we have 400 and then another 25, so that's 425. We also need to know the number of cans. So one can on the pictogram represents 100 cans. So we can see that because we have 3 cans, they've collected 300 cans. Now the question asks how many more. So we need to find the difference. We need to work out how many more is 425 than 300. And to find the difference, we can subtract, and that gives us our answer 125. Dev has 5 coins. He has £1.60 altogether. Write what the 5 coins could be. So if he has £1.60, the largest coin that he could have is a £1 coin. But he can't have 2 £1 coins because that would take us to £2, and he only has £1.60. So let's try a 50p coin. Together £1 and 50p is £1.50. Now another 10p would take us to £1.60, but we can't write 10 here because we need to use 5 coins, not 3 coins. So let's write 5p here, so that brings us to £1.55, so we need another 5p. But we can't make 5p using only 2 coins, so we must have gone wrong. Instead of 50p here, let's try 20p. £1 plus 20 pence is £1.20. If we add another 20 pence, that takes us to £1.40, and then we need another 20 pence altogether for these two coins here to take us to £1.60. So we can have 10 pence and 10 pence. £1 plus 20 pence is £1.20, another 20 pence, £1.40, then £1.50, £1.60. And we've made that total using 5 coins, so we have our answer. But there are other possible solutions for this question. We could have 50 pence, another 50 pence gives us £1, another 20 pence gives us £1.20, another 20 pence takes us to £1.40, and then another 20 pence, we get £1.60. Or we could have 50 pence, 50 pence, 50 pence, 5 pence, and 5 pence, because that gives a total of £1.60 as well. Here are 6 shapes on a square grid. Write the letters of all the shapes that are squares. So we need to remember that with squares, all the sides are the same length, and all of the angles are right angles. So for shape A, we can see that we have right angles in the corners and sides of the same length. So that means shape A is a square. Shape B is not a square. Shape B is a parallelogram because we can see that the corners are not right angles. And for shape C, though all the sides are the same length, the angles are not right angles because this angle at the top and this angle at the bottom, these are less than a right angle, and these angles at the side are larger than a right angle. So this shape is not a square because a square needs to have 4 right angles, and this shape doesn't have any. Shape D is a square because we have 4 right angles and all of the sides are the same length. And shape E is a square as well because the corners are right angles and the sides are the same length. Shape F is not a square because the angles, though some of them are right angles, it doesn't have 4 right angles, and also it doesn't have 4 sides of the same length. So the squares are shapes A, D, and E. Joe has a box of 72 chocolates. He gives 18 of the chocolates to his friends. How many chocolates are left in the box? So he started with 72 and gave 18 away. So he now has 18 less than 72. So we need to subtract. And when we do that, we get 54. So that means there are 54 chocolates left in the box. Now Holly has a box of mints. She has 10 friends. She gives them 5 mints each. She has 13 mints left. How many mints were in the box at the start? So she has 10 friends and she's given each of them 5 mints. So 10 times 5 is 50. So that means that she's given away 50 mints to her friends. And she has 13 mints left. So to find the total number of mints, if she gave 50 away and she has 13 left, we can work out 50 plus 13, so that's 63 mints in the box at the start. 50 were given away because 10 times 5 is 50, and 13 were left, so that makes 63 mints altogether. Holly takes half an hour to walk from home to school. She arrives at school at 8:25 a.m. At what time did she leave home? So we can use a timeline. We know that half an hour is 30 minutes because an hour is 60 minutes and half of 60 is 30. So we know that she arrives at 8:25, so she must leave home 30 minutes before that time. Now we can subtract the 25 minutes to take us back to 8 o'clock, but that's subtracting 25 minutes, and we need to subtract 30 minutes. So we need to subtract another 5 minutes, because if we subtract 25 and then 5, that's 30 altogether. So 5 minutes before 8 o'clock is 7:55. That's because there are 60 minutes in an hour, and 60 minus 5 is 55. So she leaves home at 7:55 a.m. Dev leaves school at 3:30. He arrives home at 4:10. How many minutes did it take for him to get home? So 3:30 is 3:30, and he got home at 4:10. So what do we need to add to 3:30 to get to 4:10? Well, first, we can add 30 minutes to get to 4 o'clock, because 30 plus 30 is 60, and there are 60 minutes in an hour, so adding 30 minutes takes us to the next hour, takes us to 4 o'clock. But then we need to add another 10 minutes, because he arrives home at 4:10. So that takes us to 4:10, and we can see that to get from 3:30 to 4:10, we added 30 minutes and then another 10 minutes, so that's 40 minutes altogether. The four sums below can be completed using only the numbers 1 to 8. Use each number once to complete the sums. One sum has been done for you. So 1 plus 5 plus 6 is 12, because 1 plus 5 is 6, and then 6 plus 6 is 12. So we have 5 and 6 crossed off. Now the difficult thing with this question is that it says use each number once, so we can't use any of these numbers in more than one box. So what we can do is just try out different numbers, and then if we find it doesn't work, we can rub out what we've done and try something else. So we have 2 plus something equals 12. Well, let's put 8 in this box here, and 2 plus 8 is 10, so we need 2 more to make 12. So we can cross off 8 and 2 to remind us that we've used those numbers, because we can only use each number once. So now 3 plus something is 12. Well, if we write 3 plus 7, that makes 10, but then we need another 2 to make 12, but we've already used the 2. Or if we tried 3 plus 4, that would only come to 7, and then we'd need another 5, but 5 has been used as well. So clearly we need to try something else, so let's start again. Instead of writing 8 in this box, let's write 7 in this box. 2 plus 7 is 9, and then we need 3 more from 9 to get to 12. So let's cross off 7 and 3. Now 3 plus something is 12. If we write 8 in this box here, 3 plus 8 is 11, and then we need 1 more from 11 to get to 12. So let's cross off 8 and 1. So the numbers we have left are 2 and 4, and 6 plus 4 plus 2 equals 12, because 6 plus 4 is 10, and then 2 more takes us to 12. So we have our answer. We've used each number once, and we've made sums that total 12. Here is part of a number sequence. The numbers in the sequence increase by 25 each time. Circle all of the numbers below that will appear in the sequence. So we have 50, 75, 100, 125. So we can see that the sequence is going up in multiples of 25. And multiples of 25 are easy to spot because the last 2 digits of the number will either be 25, 50, 75 or 00. If we continue counting in steps of 25, you can see we have 25, 50, 75, 00, and again 25, 50, 75 or 00. So the numbers that we need to circle are 650 and 900. 650 ends in 50, so will be a multiple of 25, and 900 ends in 00, so that will be a multiple of 25 as well. Shade 2 squares and 1 triangle to make this design symmetrical about the mirror line. Remember, if something's symmetrical, then we have the same on both sides, so we have the same shapes facing each other. So this square here and this square here are symmetrical, but now we need to shade 2 more squares and 1 triangle. So we need to shade this square here so that it's opposite to this square, and then if we go up, we have this square connecting the squares shaded, so we need to shade this square as well, and then we have our triangle here, so on the opposite side we need a triangle here. Now this can be tricky, but it's much easier if you turn your paper around, so rather than a diagonal mirror line, you have a vertical mirror line. That way it's much easier to spot that this square here is opposite to this square here, and this square opposite to this square, then this triangle opposite to this triangle. So it's a good idea, if you have a diagonal mirror line, to turn your piece of paper around, and then you can see what you need to shade. Write the correct sign, equals, greater than, or less than, in each circle. So here we have 9 times 3, so that's 27, and then on this side we have 8 times 4, so 32, and 27 is less than 32. Now 9 minus 3 is 6, and 8 minus 4 is 4, so 6 is greater than 4, so 9 minus 3 is greater than 8 minus 4. 9 plus 3 is 12, and 8 plus 4 is 12 as well. So that means 9 plus 3 is equal to 8 plus 4, because we have the same on both sides. And 9 divided by 3 is 3, because 3 times 3 is 9. And 8 divided by 4 is 2, because 2 times 4 is 8. So because 3 is greater than 2, that means 9 divided by 3 is greater than 8 divided by 4. Dev and Joe each buy a book. Dev pays with a £5 note and gets £1 5 change. Joe's book costs £7. How much more does Joe's book cost than Dev's book? Well, first we need to find the cost of Dev's book, and then we can find the difference. He pays with £5 and gets £1 5 change, so we can subtract the change from the amount that he pays with to find the cost of what he buys. So £5 minus £1 5 is £3.95, and if we subtract that from £7, that will give us the difference, and because the question says how much more, we know that we need to find the difference. £7 minus £3.95 is £3 and 5 pence. £7 is £3 5 more than £3.95. Here are some shapes on a 1 centimetre square grid. What is the perimeter of shape A? So we have shape A here, and we can remember that the perimeter is the total distance around the outside of a shape. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares. And it's a 1 centimetre square grid, so the perimeter is 14 centimetres. Joe places some apples on a weighing scale. The pointer shows the mass of the apples. He takes away 1 apple. The mass goes down by 120 grams. Draw the pointer in its new position on the scale below. So first, let's find the mass of the apples that he has. we can see that it's between 700 and 800, but to find the exact mass, we need to work out what each of these little lines on our scale represent. Now to get from 0 to 100, we have 1, 2, 3, 4, 5 lines. So what we can do is divide 100 by 5, because we have 5 jumps to get to 100, and then 100 divided by 5 is 20, so we know that each of these little lines stands for 20. So we have 760 here, because after 700, the next line will be 720, then 740, and then our pointer is showing 760. So he has 760 grams of apples, but then he takes away one apple and the mass goes down by 120 grams. So we need to subtract 120 grams from the 760 grams that we start with. And 760 minus 120 is 640. So on the scale, here we have 600, and because we know that each little line is 20, after 600 we'll have 620, and then this point here will be 640. Holly says 1/3 of this shape is shaded. Is Holly correct? Explain how you know. So here we have a shape made up of triangles and a square, but the square isn't the same size as the triangles, and when looking at fractions of a shape, it's easier if our pieces of the shape are the same size. So it's a good idea to split this square in half so that it's the same size as the triangles. So when we do that, we can see that we now have 6 triangles and 2 of them are shaded. But how many sixths is the same as 1/3? Well, if we find our equivalent fraction, we can see that 1/3 is the same as 2/6, and we have 2/6 shaded. So Holly is correct. 2/6 is shaded, and that is equivalent to 1/3. The other way of working out this question is to spot that the 2 shaded triangles are the same as 1 square, and that makes 1 out of 3 squares, so 1/3 shaded. This triangle here that's shaded, if we rotated it, is the same size as this triangle here that's white. So moving this shaded piece over here would mean that we had 1 whole square shaded and 3 whole squares altogether, so that would make 1/3. This chart shows the favourite snacks of some boys and girls. How many snacks were chosen by more girls than boys? So if we look at the key, we can see that girls are pale grey and boys are dark grey. So if we look at nuts, we can see that more girls than boys chose this snack because the bar that's pale grey is larger than the bar that's dark grey. With raisins, we can see that the dark grey is bigger, so that's more boys than girls. For banana as well, the dark grey is larger. For fruit bar, we have just slightly more girls than boys because this bar at the top is slightly larger than the bar at the bottom. And for cereal bar, we have more boys than girls because the dark grey takes up most of the bar. So altogether that's nuts and fruit bar, so that's 2 snacks chosen by more girls than boys. Now, how many more boys than girls chose raisins? So we can look at our bar for raisins, and this time we need to know the number of boys and the number of girls so that we can find the difference. Now if we go up and then go across, we can see that it's between 2 of these little lines, and each of these little lines must be an increase of 2, because to get from 0 to 10 we have 5 lines, and 10 divided by 5 is 2. So again, we can find raisins, go across, and we can see that that's between 10 and 12. So that's 11 boys choosing raisins. Now, if we look at the top of the bar and go across, we get to 18. So we need to find the difference. 18 minus 11 is 7, so that means 7 girls chose raisins. The total height of both parts of the bar is 18. We know that 11 are boys, and that must mean 7 are girls. Now the question asks how many more, so we're finding the difference, which means we need to subtract, and 11 minus 7 is 4. So 4 more boys than girls chose raisins. Now, which snack was chosen by twice as many boys as girls? So it's not going to be raisins, because 11 is not 2 times 7. But let's look at banana, because we can see just by estimating the size of the bars that the boys' bar is about twice as large as the girls' bar. So if we look across, we can see that 10 boys chose banana and 5 girls chose banana, because if we look across from the top of the bar, we have 15. We were already on 10, so that's 5 more to get to 15. And 10 is twice 5. So banana was the snack chosen by twice as many boys as girls, because 10 is twice as many as 5. The other bar that looks like boys might have about twice as much or twice as many is the cereal bar. But if we look across, we can see that 5 boys chose the cereal bar and only 3 girls, because the total is 8 and 5 plus 3 is 8. But 5 is not twice as many as 3, because 2 times 3 is 6, not 5. So we can't have the cereal bar. Our answer must be the banana. Calculate 3.81 plus 18.3. So we can set this out as a column addition, making sure that we have the decimal points lined up. And here it doesn't really matter, but it's probably easier if we write 18.3 on top. So write the number with the most digits before the decimal point on top, because now we can write a 0 in this empty square, and so that we don't forget, let's copy the decimal point down into our answer. 0 plus 1 is 1, 3 plus 8 is 11, so 1, 1. 1 plus 8 plus 3 is 12, so 1, 2, and 1 plus 1 is 2. So that's 22.11. Dev has 3 discs. Each disc has a 7 on one side and an 8 on the other side. He spins all the discs and adds the 3 scores together. How many different totals can he get using the 3 discs? So let's think of the different totals that he might get. He might get 8 on all 3 of his discs, so that would be a total of 24. He might get 2 8s and 1 7, so that would be 23. He might get 2 7s and 1 8, so that would be 22. Or he might get 7 on all 3 of his discs, so that would be 21. Now we want to know how many different totals can he get. So we can see that there are 4 different possible totals, so that's our answer. He could get a total of 24, 23, 22 or 21, so 4 different possible totals. 500 children started a 20-kilometre sponsored cycle ride. This graph shows how far they cycled. At what distance were exactly half of the children still cycling? So we know that there were 500 children altogether. So we need to find half of 500, or divide 500 by 2, and that gives us 250. So we need to know at what distance were 250 children still cycling. So we have the number of children cycling on this side, and 250 will be right in the middle of 200 and 300. So we can draw a line across to where it hits the line on our line graph, and then draw a line down to find the distance. If we look at this scale, we can see that each square is an increase of 2 kilometers. So that means 250 children, or half of the 500 children, were still cycling at 16 kilometers. Now estimate how many children completed the 20-kilometer cycle ride. So we have 20 kilometers at the end, and if we draw a line across, we can see that that's just under 200. Remember, the line in the middle of 100 and 200 will be 150. But the line that we've drawn is closer to 200 than it is to 150. So I would estimate 185, because that number is only 15 less than 200, but it's 35 more than 150. And that makes sense because the line that we've drawn is closer to 200 than it is to 150. So you get the mark for an estimate of between 180 and 190. Here are 5 number cards. We have 0.47, 10, 100, 1000 and 4.07. Use 4 of the cards to complete these calculations. 47 divided by something equals something. Now we can see that here we're going to be dividing by 10, 100 or 1000. So what we can do is write out 47, and then because that's a whole number, we can put a decimal point on the end. Then we can copy down our decimal point, and remember, to divide by 10 we can move the digits 1 square to the right. To divide by 100 we can move the digits 2 squares, and to divide by 1000 we can move the digits 3 squares. Now we can make the number 0.47. If we move the digits 2 squares to the right, we get 0.47, because remember, if we have an empty 1 square, so an empty square before the decimal point, we can write a 0. So we moved the digits 2 squares, which meant we divided by 100 to get 0.47. So we can cross those off. Now something times something equals 40.7. So let's take the number 4.07. How can we get 40.7 from that? Well, if we copy down the decimal point, we can see that what we're doing is moving each digit just 1 square to the left. And if we move the digits 1 square to the left, that's multiplying by 10. So we can have 4.07 times 10. This also works if we switch the numbers around. So if we have 47 divided by 0.47, that will be 100, because you can always switch the divisor and the quotient of a division problem, and with multiplication problems, you can switch the numbers around because order doesn't matter with multiplication. Calculate 544 divided by 32. So we need to work out our 32 times table. 32 is of course 1 times 32. If we add another 32, we get 64 for 2 times. We have 96 for 3 times. Adding another 32 gives us 128 for 4 times, and then we get 160 for 5 times. And when we get to 5 times, it's often a good idea to look back at the question. So taking the first 2 digits together, we have 54. So we need a number that's as close to 54 as possible, but not more than 54. So the closest number we have is 32, because 64 is too many. And because 32 is 1 times, we can write 1 in our answer line. So now we need to subtract and bring down. 4 minus 2 is 2, 5 minus 3 is 2, and we can bring down the 4, so we have 224. We can see that we're not close to 224 yet. So here we could either keep going, so keep on adding 32 to find 6 times, then 7 times, and so on, until we get to 224, or if we want to get our answer quickly, we can think 160 plus which of these numbers might give a total of 224. Well, I think if we add 64, that will give us this total. So 64 is 2 times, and if we add 5 times a number plus 2 times a number, we get 7 times that number. And we can see that when we add those, we get 224. So because we've worked out that that's 7 times, we can write 7 as the ones digit of our answer. So that's 17. And then to check, we could work out 17 times 32 and check that that gave us the answer 544. This cube has shapes drawn on 3 of its faces. The cube is turned to look like this. Draw and shade the missing shapes. So we can see that the face we have here is this face at the top. If we imagine turning the cube, then we can see that we have the arc of a circle on the face to the right at the top. So that will be about here. Then we can see that we have a triangle starting at this corner here. So that will be this corner here, and we can draw the triangle like this. So we've shaded the missing shapes. A and B are joined by a straight line on coordinate axes. The dots on the line are equally spaced. What are the coordinates of C? So we need to find the coordinates for this point here. And to help us understand this, let's zoom in on the coordinate grid. So we know that the x-coordinate for point A is 10 and the x-coordinate for B is 22. Now the difference between 10 and 22 is 12, but we have another 3 points in the middle. So that gives us 4 spaces altogether. So from one point to the next will be a difference of 3, because 3 plus 3 plus 3 plus 3 is 12. And the difference between A and B is 12. So C will be 3 more than 10, so that's an x-coordinate for C of 13. And then A has a y-coordinate of 10 and B a y-coordinate of 30. So that's a total difference of 20, but again we've got these 3 points in between. So that gives us 5 jumps and a difference of 20, so we'll have a difference of 5 as we go from one coordinate to the next, because 5 plus 5 plus 5 plus 5 is 20, and that's the difference between A and B. So the y-coordinate for C will be 5 more than 10, so that's 15. Here is a sketch of a quadrilateral. It is not drawn to scale. Draw the full-size quadrilateral accurately below. Use a protractor, angle measurer, and a ruler. 2 of the lines have been drawn for you. So if we have a sketch, we need to draw or measure the angle first. So we have 75 degrees. We can take our protractor and make sure that the cross on the protractor is lined up with the point on the angle. We can also make sure that we have the 0 line, so the bottom line on our protractor, lined up with one of the lines of our angle. Now we need to measure 75 degrees, and we can see that the 0 is on the outside scale. So we can find 70, then count another 5 little lines, and we want to draw a dot on 75. Because now we can take our ruler and draw a line 9.2 centimeters long. So we need to make sure that 0 on the ruler is lined up with the point on the angle. And we also need our ruler lined up so that our line will go through the dot that we've drawn, because that means we'll have an angle of 75 degrees. Now we need 9.2 centimeters, so that's 9 centimeters and then another 2 little lines. So now all we need to do is join up these corners and we have the quadrilateral. Joe has 2 strips of card. Each strip is 36 centimeters long. One strip is divided into 3 equal parts. The other strip is divided into 4 equal parts. Joe uses the 2 strips to make this shape. What is the total length of Joe's shape? So we can see that the length is 36 centimeters. So that means each of these rectangles must have a length of 12 centimeters, because 36 divided by 3 is 12, or 12 times 3 is 36. And these rectangles here must have a length of 9 centimeters, because 36 divided by 4 is 9. So we can write what we know on these rectangles here. So what we need to find out to find the total length is to find the length of this gap here. Now we know that this rectangle at the top is 12 and this rectangle is 9, and they line up together, so we know that this space here must be 3 centimeters. So now to find the total length, we can add 3 and 36, because 4 times 9 is 36, and that gives us a length of 39 centimeters.